Pantheon AI presents Sleep Time Compute paper. Welcome back to AI Unpacked. Today, Sarah, we're diving into something that sounds both incredibly simple and revolutionary at the same time. It's a new concept called Sleep Time Compute.
Sleep time compute. Okay, I'm intrigued. It sounds like what my laptop does when it's updating overnight. Is it something like that, but for large language models?
That's a fantastic way to put it. It's exactly that idea. Instead of waiting for you to ask a question and then doing all the heavy lifting, which is what they call test time compute, the model uses the idle time in between your interactions to think.
So it's pre-processing the information? Like, if I give it a long document, instead of just sitting there waiting for my question, it's already reading and making notes in the background?
Precisely. It's generating and storing useful information and inferences from the context you've already provided. So when you finally do ask your question, a lot of the work is already done.
Which means much faster responses. I can see the appeal. We've all been there, staring at a loading screen, waiting for an answer to a complex query. The latency can be a real killer.
Exactly. The paper points out that current methods can take minutes and cost, get this, sometimes tens of dollars. For a single complex question. They treat every query as a brand new independent event, even if you're asking multiple questions about the same document.
Right, which is so inefficient. It's like rereading an entire book every time someone asks a new question about a different chapter. So with this sleep time approach, you're spreading that initial reading cost over all the questions you might ask later.
That's the cost amortization part. It makes the average cost per query go way down. So how do they actually do it? Methodology is pretty clever. They have the LLM take the original context, let's call it C, and during that sleep time, it generates a new enriched version called C prime.
And that C prime is what's used to answer the question. The one with all the pre-computed thoughts and inferences baked in.
You got it. To test this, they had to create their own data sets, modifying existing ones like GSM-8K for math problems, and even using tough problems from the American Invitational Mathematics Examination, or AIM.
That makes sense. They needed a way to separate the context from the question to properly simulate that. Sleep, period. So what were the results? Did it actually work?
Oh, it worked. The findings are pretty staggering. They found they could get the same accuracy as standard methods with up to 5 times less compute at test time.
Wow! 5 times. That's a massive reduction in latency. So you get your answer faster. But did it actually make the answers better?
It did. By scaling up the sleep time compute, letting the model think for longer, they saw accuracy boosts of up to 13 to 18% on their reasoning benchmarks. And in those multi-query scenarios we talked about, the average cost per query dropped by up to 2.5 times.
Okay, so it's faster, cheaper on average, and potentially more accurate. It sounds almost too good to be true. Is there a catch? When doesn't it work?
Good question. There is a key factor, predictability. This whole method works best when the model can reasonably anticipate the kind of question you're going to ask based on the context. If your query is completely out of left field, then the pre-computation might not be very helpful.
Ah, I see. So it's not a silver bullet for every single use case. But for things where the task is fairly defined, like maybe a software engineering agent trying to fix a bug in a specific file, it seems perfect.
And they actually did a case study on that. For a software engineering task, they found it significantly improved performance, especially when the budget for test time compute was low. It allowed the agent to perform better even with fewer resources at the moment of action.
That's a really practical demonstration. So, looking ahead, where do they see this going? I imagine this is just the first step.
Definitely. They acknowledge that real-world conversations are more complex than just a single sleep time and a single test time. It's often a back and forth. Adapting this concept for those multi-round interactions is a big area for future research.
And they also mentioned something about representation learning, right? That this process of creating the new C-prime context is essentially teaching the model to represent information more efficiently in natural language.
Exactly. And one final really interesting idea. They suggest using sleep time compute to generate high-quality synthetic data for training future models. It could be a way to make the costly process of data generation much more efficient.
So, in a nutshell, by letting our AIs sleep on it, we can make them faster, more efficient, and even smarter in a whole range of stateful, complex tasks. What a fascinating idea.
It really is. A simple shift in perspective that could have huge implications for how we interact with these powerful models. A great reminder that sometimes the best work happens during the downtime.
Pantheon AI, your information co-pilot.
Because learning shouldn't feel like a full-time job. Take care and see you next time.